Hi everybody, welcome to the second in the series of How to Teach. Today we're going to be looking at how to teach perfect partitioning and place value. It's aimed at primary school level children, but place value carries on all the way through your mathematical understanding. So, my name is Nicola Ross. I own the Kit McGraw Education Centre, Sheffield Central, and we tutor children in maths and English, help them out a little bit, both online and in the centre. Okay, so if you want to just give me a thumbs up when you're here, and then I know who's around. If you'd like to, let's have a look at the first bit first. So partitioning basically means the position, breaking numbers apart and then recombining them together again to make it easier. It's a good technique to use written down, and then you can transfer it into your head like you would with the empty number line that we did last week. In order for partitioning to make sense, we need to understand place value. So we're going to look at that for a little while first and look at games that you can play with your child to encourage them to do place value. So all place value means is your hundreds, your tens, and your ones. We might have done hundreds, tens, and units when we were at school, but it's now hundreds, tens, and ones. I'll just move that down a little bit. So all it means is if I have a 2 in my hundreds column and 0 placeholders, it's 200. If I have it in my tens column, it's 20, and if I have it in my ones column, it's 2. And so the value of the number, depending on the place it's in, that's its place value. This is a really important concept because it starts here understanding tens and ones, or tens and units, and then it carries on when you start to teach percentages and decimals and fractions. The place value is really important, and I'd say probably about 30% of the children that come into the centre who struggle with maths, it's because of a gap in the knowledge of place value. So it's not something to be underestimated, it's a useful concept to grasp. So there are a couple of things that I use, a couple of tools that I use to help me with teaching place value. The first one are these things. These are arrow cards. Okay, now you can just print these off. There's loads of sites online where you can just print them off, laminate them if you wish. And you have your ones, you have your tens, and you have your hundreds. And they're quite nice because you can overlay them. So I'm just going to start off, show you a couple of games that you can play with your child to check their understanding of place value. Okay, so the first one that we can do, now hopefully I can show you on here, come on down onto the table. So I take my cards, I'm going to lay out my hundreds, and my tens, and my ones. I'm going to ask my child if they'll pick one card from each pile. So I'm going to pick this one, I'm going to pick this one, and I'm going to pick this one. And then when we place them back together, we've got 900, 10, and 3. And you can say to them, okay, great, what number have you got? And hopefully they can tell you that they've got 913. Okay, and then you might pick a card and they ask you what the number is, so you work it both ways. If you've got a child that likes a bit of competition, you can put that element into it. So you can pick a card, pick one from each pile, and you can see who gets the biggest number. So for example, I've just picked 813, and then they pick a card from each pile. And I'm going to change that a little bit. There we go. 978. Okay, so I got 813, you got 978. Who got the biggest number? Hopefully they'll realise that they have the biggest number. Now, one interesting thing you can do with that as well is you can, if I swap these over, a nice conversational point is, say I got 873, okay, and they got 918. If they say, oh, I've got the biggest number, I've got 918, so yeah, but 7 in the tens column is bigger than 1. So how do you have the biggest number? So it's getting them to realise that if the hundreds are the biggest, then the whole number is the biggest, and working out how the place value affects that way. The other thing you can do with these cards that I quite like is talk about addition and subtraction. So I've got 918. What happens if I subtract, take away, minus 8? What do I end up with? 910. Okay, so what happens if I take away the 10? You get 900. And what happens if I add back just the 8? 908. What happens if I add back 18? 918. So you can use them just as a game, or you can use them if you've got equations that you're working out. You can use the arrow cards to demonstrate that as well. The next one, next little piece of apparatus that I use is Dean's blocks. Okay, now you may have come across Dean's blocks before. These, remember when I went to school, we had these in wood. They're now pretty plastic colours. So you have your hundreds, you have your tens, and you have your ones. Okay, now these are quite nice to get hold of because you can use them for a lot of different things. You can also use them when you start to teach decimals as well. Talk about the first of all. So you say this is a 1, it's worth 1. This is a 10. There are 10 ones in a 10. And what children will often want to do is they'll want to stack them along, build them up to it next to each other. And then you can say, and there are 10 tens in 100. And again, you can stack them up next to each other. Any playing with these is a good thing. So they can build houses with them, they can create little rivers, whatever they want to do. Just playing with them helps them to get the idea of what you're talking about. Okay, so then we can combine these with the arrow cards. So say I choose my 3 arrow cards and I choose 132. I'm just going to come down onto the table again. So I've got 132, and then you say to your child, can you make that with the Dean's blocks? I can do 100. 30 is 3 in the tens column, so 30. And 2 ones. 132. And then you change it over and you say to your child, and you say, okay, do you want to pick a number, and I've got to find the Deans. So they'll pick a number, and you find the Deans. So you're trying to do it equally. You don't want to feel like you're just laying into your child and teaching them, you will learn this. You want to be a facilitator of learning. So it's almost like you're learning this together. You're doing it as an activity together. Okay, so that brings me to the end of all the place value little games that you can do. There's obviously lots more, and often children will come up with their own games and just go with that as well, give them some ownership of it. Just give me a thumbs up if that's all okay. Does that make sense? Okay, that's great. All right, so now we'll move on to the partitioning bit now. So, partitioning, this method is going to come in the same place as the empty number line method came in. So this is between when your child can count on their fingers, they can add on the fingers up to 10, and before you start to teach the formal written methods. So by formal written methods, I mean things like this, where you did 1 plus 3 and then 3 plus 2 and put the answers in the bottom. This is still being taught, but a bit later on than the method we're going to talk about today. So the way partitioning works is, say you have this equation. So I've got 23 plus 31. Just move that down there a bit. I'm going to do this with my Dean's blocks because we understand the Dean's blocks now, and they're good ones to practice with. So I'm going to make my 23 is 2 tens, 3 ones. We've practiced this quite a lot together, so we know. Ooh, I'm going to balance them. So we know. It worked really well in rehearsal. There we go. 3 ones. Maybe just put them on the table. There we go. So that's my 23, and then I've got my 31. 30 and 1. And what we're going to say to each other, we're going to add up the 10s first. So I'm going to add up my 20 and my 30. Oh goodness, a couple missing. There we go. I'm going to add my 20 and my 30 first of all. So 20 plus 30 gives me 50. And then I'm going to add up my 3 and my 1. Gives me 4. So now I have 54. So 23 plus 31 equals 54. Okay. Now the way you'd write that down, I'll just move these out of the way a second. Once a child's understood them okay with the Dean's blocks, you can then do that written as well. So the way I'd write it down, just come this way, is you take your 20 and your 30, 20 plus 30, and I would at this stage, I still say 20 plus 30, not 2 plus 3, because you're still getting them used to the place value. So 20 plus 30 is 50. And then I'm going to take my 3, add my 1, 3 plus 1 equals 4. And then add them two together, gives you 54. And again, we're only writing this down until the child makes sense of it and can internalize that visualization. And then they can do it in their heads. They don't need to keep writing it down. This is just a means to an end in terms of mental arithmetic. Just give me a thumbs up if that makes sense. If you want to hit the surprise face if it doesn't make sense, and I'll run through it one more time. Okay, lovely. Now I've talked quite a lot about play and games during today. There was a study cited by Dr. Karen Purvis in a recent science journal, where she said that scientists have now determined that it takes around 400 repetitions for a synapse to be created in the brain. So we learn by building brain pathways, so the synapse brain pathway. It takes 400 repetitions for that to be completed, unless you're doing it through play. If you're doing it through play, it takes between 10 and 20 repetitions. So if you don't want to be repeating yourself again and again and again, make it fun. Find the fun in it. Find a game to play. Let the child take ownership. If they come up with ideas for a game and then keep changing the rules, that's absolutely fine. Because as long as they're playing, that synapse is going to be developed much, much faster than if we were just didactically talking to them. Okay, so that's everything we've got today to cover. Next lesson next week, so Wednesday 8:15 next week, we're going to be looking at how you use place value to teach fractions, decimals and percentages and converting between them. This starts to come in at year 4 and then obviously carries on all the way up through GCSE. We'll start at the year 4 level next week, so we'll look at what's going to be taught there. Okay, so if there's anything you would like me to cover next week, or in the weeks to come, I have a list, but if you want to add to it and anything, just pop that in the comments and I'll look at when we can cover those. If there's something you would like to discuss about your individual child, then again, just drop me a PM and I can get back to you and we can have a talk about things that might be happening. Okay, lovely. Well, thank you ever so much for watching and I'll see you next week. Bye-bye.